Hello. So here is the last little part of chapter 9 that we are going to cover. Excuse me. I have notes 9.6. I'm not quite sure what that number means. But it's these two laws, the law of detachment and the law of syllogism. We are actually going to do a little project based on the law of syllogism. But first we're going to practice the two laws. But first you need to figure out what they are. So here are the two definitions. This is both of them on the same slide. Here's the law of detachment. Here's the law of syllogism. Okay? If I were you, I would pause, write them down, and then keep going so that you can hear what I have to say so that you can make any notes that you want about these definitions. These are like the official definitions. Notice that the law of detachment is in an if-then statement. Pretty much the rest of our rules that we learn here in our geometry portion of Math 1 will be in the form of if-then statements, of conditional statements. Okay? So the law of detachment says that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So what this means is if you have a conditional statement, okay, so like one of the ones you did last week was if I can see stars at night, if I can see stars, then it's night, okay? So if I can see stars, if I see stars, then it's nighttime, okay? So remember the hypothesis is the first part, the if part. So if I see stars. So if that's true, so if you see stars, then it must be nighttime, okay? So the way this is going to be presented to you is that you'll get a conditional statement such as this, and then you'll get a piece of information. So say you're given this statement, if I see stars, then it's night, and then you're told, I could see the Big Dipper. Okay, well, the Big Dipper is made of stars, right? So being able to see Big Dippers means that this part is true. You saw stars. So therefore, that part has to be true. So your conclusion would be, well, then it must be nighttime. Okay? We're going to do some examples, I promise. I'm going to erase this, and I'm going to move on to the law of syllogism. Okay? The law of syllogism is a little bit less tricky than the law of detachment. To have the law of syllogism, you have to be given two if-then statements. Okay? If you are only given one conditional statement, then it can't be trying to use the law of syllogism. There has to be two statements. So one statement, two statement. You could be given 27, okay? But for our examples, you'll be given two. And then your conclusion is also an if-then statement, okay? So whereas your conclusion on the law of detachment was just something like I can see, it's nighttime, the law of syllogism will always be written as a conclusion with in the if-then form, okay? So the law of syllogism says that when you have the first if-then statement, you have a hypothesis. So if I can see stars, then it's nighttime, right? Okay? And then your second statement takes the conclusion and makes it the hypothesis. Exactly. So if I see stars at night, then, if I can see stars, then it's nighttime. Okay? And then number two would be, if it's nighttime, then I'm tired. So if I can see stars, then if I see stars, then it's night. That's the first statement. If it's night, see how it kind of just goes So then it goes from this conclusion to this hypothesis. Then, what did I say? I'm tired. Tired. I'm sorry you can't actually read that. Okay? So the two pieces in the middle, this conclusion and this hypothesis, need to be the same. Okay? And if that is true, then you can make a conclusion that if you see stars, then I'm tired. Okay? So your answer, your conclusion would be a new if-then statement that takes the original hypothesis, the first hypothesis, and the last conclusion to make a new if-then statement. Let's do some examples. So notice in the question it says using the law of detachment. Okay? So we only have the one if-then statement, which is fine when we're trying to use the law of detachment. Okay? So that if-then statement says, if two segments have the same length, then they are congruent. Okay? And then it gives you this little piece of information here. Okay? It says, you know that segment BC is equal to segment XY. Okay? Segment is equal to segment. Segment equal to segment means that the segments have the same length, right? So what they've told us goes with the hypothesis, okay? And so therefore our conclusion would be they're congruent, okay? Which would be that sign right there. So that's your conclusion, is that because these two pieces are the same, or are saying the same thing, then our conclusion is correct. So your answer is that they're congruent. Let's do another one. If a figure is a square, then it is a rectangle. Okay, so so we need to know if whatever we're talking about is a square, because that's our hypothesis, right? And then the next piece of information they give us is that we know that this quadrilateral is a square. Okay, well, hypothesis, statement, information is the same, right? They're both square. So therefore, using the law of detachment, we can say that ABCD is a rectangle. So that's your answer. That's the statement that you can make. Okay? Now, what I don't have an example of, is, maybe hit pause and make sure you write this down because I'm going to erase this stuff, is what if, in this process, what if it had said that instead of maybe that it was a rectangle? Okay? Well, this information that they've given you does not match the hypothesis, so we cannot make any statement. Okay? So you say, what statement can you make? None. Or you could say, no statement can be made, or we don't know enough, or something of that sort. Okay? All right. So now it's asking about the law of syllogism. One of the ways that you realize that it's asking about the law of syllogism, besides it saying that, is that if you look at the question, it has two if-then statements. Okay? So remember that you have to have two if-then statements. Okay? And the conclusion of the first one, you have to have at least two. Okay? For your examples right now, you're going to have two probably. So the first conclusion has to be exactly the same as the second conclusion. The second hypothesis. Okay, so the end has to be the same as the beginning. Is it? It is not exactly the same, right? So we can't do anything. Okay. Always make sure you write something, none or can't make a statement or something like that, so that I know you didn't just skip it, okay? So then here we have our two statements. We've got one, we've got two, okay? We need to look at the statement, the conclusion, okay, and the hypothesis. The conclusion, first conclusion, the second hypothesis. Are those the same? Golly, no, they're not the same. You don't have to read it. This one's a whole lot longer, right? So it must not be the same. So the answer is, again, none. Okay, so I just realized I actually don't have an example of one that actually works. So let me, I'm going to create one for us here. Okay, so if it is raining, then soccer practice is canceled. If soccer practice is canceled, then I can do my homework. Okay, so we know this is syllogism. It's asking about this law of syllogism because it's giving us 1, 2, okay, and because either I've just told you that or the question says, okay, and so we need to look at the first conclusion and the second hypothesis, and are they exactly the same? They sure are. So that means that we can take that first hypothesis, if it's raining, and the second conclusion, then I can do homework and have a conclusion, and that's our answer. So in a syllogism, your answer will be another if-then statement or none. And in the law of detachment, your answer is some fact. Then it's a square or whatever, okay? Make sure that you are asking questions in class about this.